Okay, so we were left off here. So now we're going to look at the first example on identifying unique hydrogens. So if you were to look at this molecule, the first hydrogen right here. So I'm going to draw it in paint. So I have the carbonyl group with the carbon, and I have 3 hydrogens. So the first one, second one. So and then we have the O, and then we have like C, H2. So if we were just to look at this part right here, so are they unique hydrogens or different hydrogens? So take this hydrogen is like, oh, I look to the right, I see a carbonyl group. I look to the left, I see nothing. This hydrogen, I look to the right, is carbonyl, look to the left, nothing. So this hydrogen, same thing, right? So that's why all these 3 hydrogens are the same. Okay? So if we were to move over, so we're up to here, carbonyl of the OCH2, and then with a CH2, and then we have CH3. Okay, so now if we were to look at these 2 hydrogen right here, so this hydrogen, I look to the left, I see an oxygen that's connected to the carbon. I see an oxygen, and then to the right I see a carbon with 2 hydrogens, and this hydrogen, I see the same thing. So these 2 are the same, but of course it's different from these 3. So then we look at this one. Okay, and then look at this one. Change of color. So now it's this one. Okay, the color is like the same. So look at this one. So just give me. Okay. So now look at this one. So as I look to the left, I see carbon with 2 hydrogens. I look to the right, I see carbon with 3 hydrogens. So it's different as well. So if I were to look at this last one. So this hydrogen, look to the left, see carbon with 2 hydrogen, and look to the right and see carbon, and then see nothing. And it's the same for these 2. So that's why this one, these hydrogen are unique. These 3 are different from the rest. So now if I were to make it confusing, so if I ever make this molecule look at this. So now we have this 2 and this 2. So if we're to look, so if these 2 hydrogens look to the left with hydrogen with carbon with 2 hydrogens, look to the right, carbon with 2 hydrogens. So wait, I think I confused myself. So still different, because to the left it has 3 hydrogens, to the right it has 2 hydrogens. Okay, so that's it with that. Okay, how do I So let's move on to the next one. So this molecule, so let's draw it out. Okay, so we have a carbonyl group with CH3 and then O and then CH and then CH3. Okay. And then here we have C. We have CH2 and then CH3. So why we say that all these are different? So this hydrogen look up, carbon to hydrogen to oxygen to another carbon. Look down, methyl group's different. Now if you look at this one, so to the left this is carbon with all these substituents, and then to the right is, you know, nothing. So it's different. And if you were to, so now we have 1 type, 2 type, 3 type, 4 type, and 5 type. That's why here we have a 3, which is 3 to 1 to 3 to 2 and to 3 ratio. Here 3 1 3 2 3 ratio. So if you can basically teach yourself how. So I'm gonna skip 3, I'm gonna go to 4. It's pretty self-explanatory, but I'm gonna do this one as well, just in case. So I'm gonna draw the number 4. So O C So all these hydrogens are the same, because if you look to the left is carbon connected to oxygen and to other methyl group. For this one it's the same. So if you look to the left, it saw oxygen connected to 2 other methyl group. So that's why all these oxygens are the same, and that's why I want to cover. So, and then next we have these benzene derivatives. So this one's easy. So if you look at this 2 hydrogens, they're the same, because let's take this one. So you look over on this side, it saw an oxygen connected to methyl group, and so the other side I see this hydrogen. Same thing here.